Hi everyone, this is Cassidy, and today I'm going to be going over a colligative property problem. Specifically, it's osmotic pressure. So what is an osmotic pressure of a solution prepared by adding 13.65 grams of sucrose to enough water to make 250 milliliters of solution at 25 degrees Celsius? Okay, and then it also gives us the molar mass of sucrose and the R value. So I'm going to write out my equation for osmotic pressure, because that's going to help me figure out what I need to solve this problem. So it says, what is the osmotic pressure of the solution? So I know that's what I'm solving for. I'm solving for that pi looking thing, which it's not pi. It's not 3.14. It's just the variable to represent osmotic pressure. Okay, what else do I need? I need my R value, but lucky for me, I was given that. I need temperature. Now remember, our R value right here has Kelvin. So this temperature needs to be in Kelvin. They give us 25, so let's solve for Kelvin. Remember, you just add 273 to the number. So we would use 298 Kelvin. Okay, we're left with I and then molarity. I is the Van't Hoff factor. It's asking the question, what is our solute breaking down into when we put it into water? Well, sucrose is all covalently bonded together. It's not an ion. So it's actually going to only break down into itself. It can't break down any further. It's not going to break up into carbon, hydrogen, and oxygen. Nope, it just stays the same. So our I value is 1 here. So I will write that right here. Okay, so look, we're basically done with the problem. We just need our molarity. So our molarity is moles per liter. What does our problem give us? It's giving us 13.65 grams to enough water to make 250 milliliters of solution. So it's giving us grams, but we need moles. So what do we do with that? We're going to use molar mass. So we have our grams of sucrose, and we have to figure out the moles. To do this, we use our molar mass. So it's telling us in 1 mole of sucrose, we're going to have 342 grams. So let me get my calculator out. When we divide all of that, we're going to get 0.0399 moles of sucrose. So our molarity is going to be equal to that on top. And then on the bottom, it's the liters of solution. They gave this to us in milliliters. So I would have to make it liters like that. Remember, you just got to move the decimal place over 3 times or divide by 1,000. Our molarity is now going to be 0.16 moles per liter. Write it like that, moles per liter. Okay, so our final equation, we'll put it in blue. We're solving for osmotic pressure. Our I value is 1. Our R value was given to us. Oh, I totally missed our molarity. Good thing we can just scooch that over. Our molarity looks like that. There's our R value, there's our temperature, and we put it all together and we get 3.9 atm, and that is going to be the osmotic pressure of this solution.